Hello students, good morning and welcome to your beautiful channel that is 33.physics for you. Now in this video lecture we are going to solve a solved example of chapter 1 which is based on flux. That is example 1.11. Right, example 1.11. The electric field components in figure 1.27 are E of x. Electric field is a function of x, that is it depends on distance x, which is given as alpha x raised to 1 by 2, and electric field along y and electric field along z axis is 0. So electric field is present only along x axis, which is a function of x, and it is given as alpha x raised to half. Electric field along y and z axis is 0, in which alpha is given as 800 Newton per coulomb into meter raised to half. Calculate A, flux to the cube. First thing is we have to calculate flux to the cube. B, the charge within the cube. Assuming A equal to, we have to take A is equal to 0.1 meter, where A is the side of the cube. So if we draw figure, this is the cube which is given in the figure. The length or the side of the cube is A. It is kept in such a way that one of its vertices lies at the origin of the coordinate system. This is x-axis, let us say. So it is kept in such a way that one of its side is along the x-axis. Right? Let us say this is y-axis, and here we have z-axis. This point is origin O. Cube is at a distance A from point O. Cube is at a distance A from point O. We have to find net flux to the cube. Now here we know that the formula for flux is E dot A, and that is equal to EA cos theta, right? We already discussed that. Flux phi is equal to vector E dot vector A, which is equal to EA cos theta. Here side is given as A. So here area of any surface of cube or side of cube will be A is equal to A square. This will be the area, right? A into A is A square. So EA cos theta. Now as we have discussed that area is a vector quantity, and for each surface it is perpendicular to the surface. So let us give some name. Let us say this upper surface, let us write A, B, C, D, E, F, G, H. So if you consider surface E, F, G, H, right? E, F, G, H is this surface, right? So area for that surface will be vertically upward, right? In vertically upward direction. So for this surface E, F, G, H, area will be in upward direction, right? While electric field is in this direction. So clearly you can see that area and electric field both are perpendicular to each other. And if electric field and area are perpendicular to each other, flux will be 0 because cos 90 is 0, right? Cos 90 is 0. In the same way, for the bottom surface, for this surface, that is A, B, C, D, area will be in downward direction. This is the direction of area, and electric field is in this direction. Again, angle is 90 degree between area and electric field, so flux will be 0 for the surface A, B, C, D. In the same way, if you consider surface ABFE, ABF is the front surface of the cube, area will be towards you, right? Area vector will be towards you, and electric field is in this direction, right? Something like this. Area is towards you and electric field is in this direction, so angle will be 90 degree. So for surface ABFE, flux will be 0 again. And in the same way for the back part, that is DCGH, area will be inside the board, right, entering inside the board and perpendicular to it, and electric field is in this direction, so again 90 degree, flux will be 0. So you can write for surface or for surfaces E, F, G, H, A, B, F, E, A, B, C, D, this one, and D, C, G, H, area is perpendicular to electric field, and hence flux will be 0 for these surfaces, right? Flux will be 0 for these surfaces. So only two surfaces are left, this one, this surface, and this surface. These two sides are left. Now for these two sides, for side B, C, G, F, area will be in this direction, right, and electric field is also in this direction. And for surface A, D, H, E, area will be in this direction, right? Why? Electric field will be in this direction, so both are in opposite direction. Let us give this surface as A1 and this be surface 2. A, D, H, E be surface 1 and B, C, G, F be surface 2. Therefore, the total flux will be, or the net flux will be, flux phi will be equal to flux due to surface 1 plus flux due to surface 2. For rest it is 0 as we have discussed. Now for 1 it is actually vector E1 dot A, right, plus vector E2 dot A2. Let me write A1 and A2. So this is equal to E1 is alpha. Electric field is given as alpha x raised to half. So for first surface, this surface ADHE is at a distance A from point O. So alpha A raised to half, right, into area is A square and cos 180 degree. Why cos 180 degree? Because both are in opposite direction, right? Both are in opposite direction, so 180 degree. If you want, you can write like this also. Vector E1 dot A1 will be equal to alpha A raised to half I cap dot A square into minus I cap. Why minus I cap? Because this area is along negative x-axis, so minus I cap, right? So this will be something like a alpha A raised to half into A square with negative sign, right? Here also cos 180 is minus 1, so this will be equal to minus alpha A raised to half into A square, plus what about E2? E2 will be alpha, what is distance of this surface from point O, A plus A. This surface is at a distance of A plus A, that is 2A from point O. So plus alpha 2A raised to half into A square, and both are in same direction, so cos 0. So plus alpha 2A raised to half into A square, cos 0 is 1. Or E2 dot A2, right? So alpha 2A raised to half I cap dot A square I cap, because both are in x direction, both are in the same direction, that is along positive x-axis. Now you can see that alpha A square we can take common, right? Let us take alpha A square common. So flux phi will be equal to alpha A square common in bracket minus A raised to half minus 2 raised to half A raised to half, right? So this is equal to alpha A square. Actually this is plus, sorry, this is plus. Let us take A raised to half common. So this is minus 1 plus 2 raised to half, root 2 is 1.414. So 1.414. So minus 1 plus 1.414 will be equal to alpha A square into A raised to half into 0.414. So this is equal to, what is value for alpha? Alpha is given as 800 into A is 0.1. So 0.1 square into 0.1 raised to half into 0.414. Let us simplify this. So 0.1 root of 0.1 will be 0.316 something into 0.1 into 0.1 into 0.414 into 800 will give you 1.047. This is 1.047 34636, right? Newton meter square upon Coulomb. Newton meter square upon Coulomb. This will be the flux associated with this cube. Clear? Look, what you have to remember is where flux is 0 and where it is non-zero. If electric field and area both are in same direction, flux will be positive. If electric field and area both are in opposite direction, then flux will be negative. And if electric field and area both are perpendicular to each other, then flux will be 0. So for the four surfaces or four sides of the cube, these four sides, right, flux will be 0 and flux will be associated and flux will be associated with only two sides, that is side 1 and side 2, right, and that we have calculated. Now here we do have one more part B, the charge within the cube. We have to find the charge within the cube, right? So we have to find Q. So we know that flux phi is equal to Q by epsilon naught. So this implies that Q will be equal to phi into epsilon naught. Now phi we got as 1.047 into epsilon naught is 8.854 into 10 to the power minus 12. So 1.047 into 8.85 will give you 9.26595 into 10 to the power minus 12. If you want, you can write 9.3 into 10 to the power minus 12 Coulomb. 10 to the power minus 12 is pico, right? So if you want, you can write 9.3 pico Coulomb. Clear?